Hello and welcome back for another VMK in the C++ series. In this VMK, I'm going to go over what a virtual destructor is for and how and when to use one. So let's go into Visual Studio and just open up a blank project here. So right now all we're doing is outputting a string of text to the screen. So when I run this, we can see it just shows www.manicnose.com. Okay, so virtual destructors. You want to use a virtual destructor anytime that you're creating classes that are going to be inherited from something else. If you're not using inheritance, you don't have to worry about virtual destructors. So let me demonstrate. Let's say that I'm going to create a class called animal. And this class is going to be the base class, which we'll be using for extending the animal class later on. So right at the top here, I'm going to create a definition. Okay, so as we see, I've created this class called animal. Inside of the constructor, I just print a string of text that says animal constructor called, and in the destructor, do the same thing that just says animal destructor is called. So now, if I go into the main section and actually declare a instance of animal, then we can see when these constructors and destructors are being called. So animal, I'm just going to define a animal pointer p. It's going to be equal to a new animal, and immediately we're just going to go and delete p. Okay, I'm going to run this and take a look at the output. Notice that we get what we expect. We go and construct the animal when we called new, and when we call delete, we're just going to go and destruct that animal. So everything seems to be working correctly, and as a matter of fact, everything is working correctly. We are not inheriting anything from animals, so we do not need to make the destructor here virtual. But now, let's go and extend animal out into something more specific, see what happens when we go and construct and destruct this. Okay, so now I've created this new class called bear, which inherits from animal. And when the bear class gets constructed, we're going to show bear constructor called. When the bear gets destructed, we have bear destructor called. Down below, we're going to use bear. So we're going to create a bear pointer for a new bear. And immediately, we're going to go and delete the new pointer for the bear this time. So let me run this. And again, we appear to be getting what we are expecting. So when we call the bear constructor over here, what needs to happen is it goes into our code for our bear constructor, but bear constructor can't get constructed until first we construct the animal constructor. So it does go into here first. And we can see that because it calls animal constructor is called, then it calls bear constructor, and then when we call delete on p, then the bear destructor gets called first, and then the animal destructor gets called. So that's the order of events that happens when we go and construct this inherited bear class, which inherits from animal. And again, everything seems to be working correctly. However, right now, you have opened up the possibility to making mistakes. And here's an example of how I can demonstrate this the easiest way. If I change my definition here from bear to animal, so this is completely valid. I say I'm going to have a pointer to an animal, but instead of constructing an animal, I am actually constructing a bear. A bear is an animal, so we are able to assign this new instance of this object to this pointer here. Then when we call delete, we're going to be attempting to delete the bear. Let's run this code and see what happens. So notice here we've got a problem. We're calling the animal constructor, we're calling the bear constructor, but when we go and delete, we only delete the animal destructor. We're not actually deleting the bear, which is a problem. If we had some stuff in here that needed to be cleaned up, it never gets cleaned up. So this is where we do need to make sure that we define our base class's destructor as being virtual. So notice now, if I just add the keyword virtual in front of animal and rerun the exact same code, now everything works correctly. We get animal constructed, bear constructed, but then when we go and delete the animal, we actually do delete the bear before we delete the animal. So this is what we are expecting to happen in C++. So you may ask yourself, well, when do I ever use this kind of notation? Why would I be assigning a pointer to an animal when in fact I'm actually using a bear? Well, it turns out that this is actually quite common. When you're building games, you want to use polymorphism in your game design so that you can make generic attributes at your base class level and then extend those out at the derived classes that use your base class. So the base class here is animal and our derived class here is bear. So let me demonstrate this. I'm going to go into our base class definition and create a virtual function called, let's say, attack. I'm going to make it purely virtual, which means that animal does not define what attack is. However, if I try to compile this code right now, you notice the compiler complains. It says, well, I don't understand this because attack has to be defined for animal, but bear is not defining what this attack function does. So inside of the bear class, we do need to define what does this attack function do. The way I'm going to do that is just define a attack function, say it's going to be overriding the base definition, and then in here we just print a message saying bear is attacking with his claws. So now if I were to, well actually let me extend this out even further. So in a typical game you would have this kind of construct where you have an animal that has different kinds of attributes associated with it, and then each different kind of derived class is going to use those attributes defined at the animal level. So for the bear, we have this kind of attack. Let me create a new class called crow, which also has a constructor and a destructor, and it also has an attack. But this attack is different from the bear attack, whereby the crow will be attacking with her beak. So now we see that we've created two different kinds of animals. There's a bear animal and a crow animal, and both of them can perform this action called attack. Now inside of our games, we're not going to be managing individual pointers like I was defining up here. Most likely what we're going to be doing is creating some sort of std vector that will contain all these different kinds of animals that we want to be playing around with. So we're going to have a vector of animal pointers. Just define this as v. And for this to work, we need to make sure at the top here we include vector. Okay. And now let's just try compiling. Oh, I'm missing a semicolon here. Let's try that. Build this. Okay, so that builds. So we have a vector of animal pointers, and what we're going to do is just stick some animals in here. So we're going to push back a new bear, like so, and let's also push back a new crow. Now that we have that, we want to iterate over each of those. Each one is containing an animal in V, and for every single animal we want to perform some sort of action. So let's say we want to have each animal perform its attack, and then after it's done attacking, then we're just going to go and delete it. So maybe I'll do something like this. If I run through this code, oh, I have a typo here somewhere. Let's see. Oh, over here should be an open bracket, not a brace. Okay, let's try running this. Okay, so now we can see we're constructing an animal, which is actually a bear. We construct another animal, which is a crow. Then the bear is attacking with his claws. Then we destroy the bear, and then we destroy the animal that's associated with that bear. And then the crow is attacking with her beak. Crow is destroyed. Animal that's associated with that crow is destroyed. And everything is cleaned up. If, however, we were to remove this virtual keyword and try rerunning that code again, here we can see that we again have that same problem we had before. We construct a bear animal, we construct a crow animal, the bear attacks, but we only destroy the animal part of the bear, not the bear destructor itself. Similarly with the crow attacks, but the animal destructor is called, but never the crow destructor. So we basically have a memory leak here. So for that reason, anytime you're using any kind of inheritance, you should always have the virtual keyword in front of your destructor of your base class to tell C++ that anything that you're deriving from your base class will have a virtual destructor, so that when you go and destroy things, that the appropriate destructor gets called and everything gets cleaned up properly. So that's what virtual destructors are for. If you have any questions about this VMK, head on down to the forum by clicking on the thread link beside the VMK and post your questions there.